So today we are looking at statistical sampling. Statistical sampling. Then we also just look at an introduction to data visualization. Okay, so let's go right in. Statistical sampling. For you to understand what sampling is about, we have to first look at what population is, and then we'll look at what a sample is. Then we'll be able to talk about why sampling is necessary. What is population? In stats, population is a set of similar items or events which is of interest for some investigation or experiment. A common aim of statistical analysis is to produce information about a chosen population. So that's it. A population is a set of similar items or events which is of interest for some investigation or experiment. The event could be students that pass an exam, children that take breakfast before going to school in the morning, whatever it is, or teenagers in a country, that do a particular thing. So the universal set of such items or events is what constitutes the population. What then is a sample? A sample refers to a smaller, manageable version of a larger group, which is the population. Okay, a population is a subset of the sample. Population is a superset of the sample. I did say before that population is a universal set, while the sample is a subset of the population. So the sample is a subset of population containing characteristics of the larger population. Samples are used in statistical testing when population sizes are too large for the test to include all possible members or observations. Okay, so when it is not feasible to work with an entire population, then we have to resort to the use of samples. Okay. The sample should represent the population as a whole and not reflect any bias. Now, so why do we do statistical sampling? Sampling has to do with ways and methods of extracting, use of some methods for extracting samples from a population. Okay. So now in sampling, you have to set the criteria, the basis for extracting the sample from the population. And this must be so defined in such a way that the sample you get from the population will be adequately representative of the population. Okay, sampling methodologies. Statistical sampling may be broadly classified as probability sampling methods, also called random sampling, and non-probability sampling methods. The statistics care must be taken to ensure that the sample is collected in such a way and manner that ensures such samples are adequately representative of the population. That's the key. Okay, the important thing is that the sample must be extracted in such a way that you can use that sample to carry out computations, to carry out analysis, and draw conclusions about the population based on the result gotten from analysis on the sample. Okay, so whatever you do with the sample, your interest is the population, not the sample. So you have to extract the sample in such a way that that sample will have the characteristics of the population. Okay, that is why sampling is an important topic in statistics. All right. Samples are used to investigate properties of the population from which they are drawn. Are we following? Are we following?
Yes, sir.
Let me give an example. Let me give an example. Now, let's say, for example, you want to have the mean height, the average height of GSS 3 girls in public schools in Nigeria. Okay. The average height of the GSS 3 public school students in Nigeria. The average height. And now, if you use a sample, you draw a sample from the population, and then you use that sample to compute, you compute the mean of the sample, right? So what we are saying is that the mean that you calculate with, you get with the sample will be taken as the mean of the population. Even though you are working with a sample, the mean you are going to get, we are not going to say it's the mean of the sample. We will say what? That is the mean of all the GSS 3 students in public schools in Nigeria. Is it clear? Is it clear to everybody? Am I audible? I hope my explanation is clear.
Yes, sir. Yes.
Okay. All right, so probability versus non-probability sampling. Now, sampling can broadly be categorized as probability and non-probability sampling. Probability sampling, this method ensures that each unit in the study population has an equal chance of being selected. Now, probability sampling is the popular method of sampling. Okay, like I do say from time to time, probability is very important in analytics. Very, very important. It's one of the basis for most of the things that are done in data analytics. Non-probability sampling, this method uses non-random sampling from the population, not random samples from the population that you want to research on based on specific criteria such as convenience. Okay, such as convenience. So let's take the GSS3 example, GSS3 research example. Uh, uh, you know, let's use that as an instance. You may decide to just visit the GSS3, the schools that are close to you, that are not far away, that will involve less uh, expenses on transport and other things, and then just collect your sample and go ahead with the research. Okay, that's convenience sampling. You have chosen a sample based on convenience. You know, most of the time when you do that, you don't get the expected result, don't get the correct results. Okay, your results, the quality of the outcome will be quite poor. Okay, but when you do raise random sampling, then the sample is usually more representative of the population. Probability sampling. In this type of sampling, each research unit in the population must have equal chance of being selected. It's also sometimes called random sampling. Okay. So the probability sampling methods include simple random sampling, stratified sampling, cluster sampling, and systematic sampling. Okay, so we are going to look at this one after the other. By the way, that's more important to us. It's probability sampling that we usually work with. Okay. Simple random sampling. Simple random sampling is used when we say sampling. The word sampling, what does it actually mean? Can someone tell us? What is sampling? What is sampling? From what we have learned so far, how would you define or describe sampling?
Uh,
Done. Okay, please come again.
Process of
Sampling,
taking predominant
the
number.
process of collecting data.
Okay. The process of selecting data. Okay. Thank you. This is still what you were saying something as well.
Yes, sir. I say it's the process of taking predominant number of observations from a larger population.
Okay. All right. Thank you. So, yeah, so sampling is the process of drawing a sample from a population, using various statistical methods. The process of using, various tools and techniques in collecting samples from a population. Okay, so sampling is the action of collecting samples. Okay, so now there are different methods of doing that. Like I said different methods can be used. So one method is this simple random sampling, which is a probability sampling. A simple random sampling is used to collect random sample from an entire population where each unit has an equal chance of selection. This is the most common way to select samples. To compile a list of the units in your research population, consider using a random sample generator. There are several free ones available online, such as random.org, calculator.net, and random.org. number generator dot org. Simple random sampling, can be, you can use different methods, even what like lucky dip, for example. That's the simple random sampling. Mhm. Stratified sampling. Stratified sampling. Hope the simple random sampling is clear. Hmm? Let me give you an instance. Let's say in a class, you want to get um, you want to get 3 persons to come out, okay, to do something, maybe to do a presentation, to answer a question or whatever. Okay. And then you can just write a series of items on a piece of paper, roll it and put them in a can and shake it and get people to choose from it. I'm sure you have done something like that before, right?
Yes, sir.
Is that right? That is simple random sampling. Okay, stratified sampling. Now let's pay attention to this. It's very important. Stratify simple random sampling is very, very important. Okay. A lot of times we use simple random sampling. Actually, many times we combine various types of sampling, but usually simple random sampling is involved most times. Okay. Stratified sampling collects a random of In stratified sampling, we collect a random selection of a sample from within certain strata or subgroup within the population. Each subgroup is separated from the other on the basis of a common characteristic such as gender, race, or religion. This way, you can ensure that all subgroups of a given population are adequately represented within your population. 1 minute, please. Okay, so in stratified sampling, you categorize the population into groups, using some predefined criteria. Now let's look at cluster sampling, then um, we'll try to connect both of them so you see the difference. Cluster sampling is a process, they have similarities. That's why I'm saying this. Cluster sampling is a process of dividing the target population into groups called clusters, just like the other one. Okay? A randomly selected subgroup of these groups then forms your sample. Cluster sampling is an efficient approach when you want to study a large geographically dispersed population. It usually involves existing groups that are similar to each other in some way, e.g. classes in a school. There are 2 types of cluster sampling: the single one-stage cluster sampling, when you divide the entire population into clusters; multi-stage cluster sampling, when you divide the cluster further into more clusters in order to narrow down the sample size. Okay, now let me ask you, what do you think is the difference between stratified sampling and cluster sampling? Can you see any difference? Any difference? Hope I'm still audible. Am I audible? Yes or no? Now, as can be seen, now if you look at stratified in cluster sampling, you group the population into clusters, right? And then you choose from within the clusters. Let's say, for instance, you want to carry out um, some investigation in, across Nigeria. You can decide to group, to break the Nigerian population, um, into geographical zones. Okay, just like have south, south, southwest, north, north, and all that, right? I think we have 6 geographical zones like that. And then you can choose, let's say, for example, within the geographical zone, you can choose a state and then work with that state. Okay? Are you following? So that way, you choose a state or two from each geographical zone, and then you go ahead to collect your samples from within those particular states that are chosen. That's cluster sampling. You see that in cluster sampling, you actually don't work with all the zones, rather all the states or all the cities. You just choose from within them. You choose from among a group or groups that have similarities. Okay. For example, you are in the north area now. We know that those northern states may have some similarities, similar characteristics. So within that, you choose some from there. You go to south, you choose from there. That is cluster sampling. Okay. But when you are talking about stratified sampling, you are using some common characteristics. Okay. For example, let's say you are using something like um, income group. Okay. Let's say you are doing an investigation and then you decide to use income group. You choose people from the high income group, you choose people from the medium income group, you choose some from the lower income group, so that your investigation will cut across the various strata. You don't get it. Something like that. That is stratified sampling. Okay. So they are kind of similar, but there's a slight difference. Systematic sampling. In this type of sampling, it draws a random sample from a target population by selecting units at regular intervals starting from a random point. This method is useful in situations where record of target population already exists, such as record of an agency's clients, enrollment list of university students, or a company's employment records. Any of these can be used as a sampling frame. Let's say, for example, you want to carry out investigation on students, okay? Maybe JAM students or students of a university, right? Now, You can decide to use systematic sampling. Maybe you just pick the amount number, okay? You use random sampling to determine where to start from, the particular student to start from. Then from there, let's say you decide, okay, going by the serial number of the mark numbers, you can decide to take every fourth or fifth student. Okay, you pick a student, you count 1, 2, 3, 4, then the fifth one you pick that. 4, 5, 6, 7, 8, the 10th one you pick that, just like that. So when you do that, that is systematic sampling. This works when a record of the entities involved already exists. Okay, is it clear? Is it clear, please? I have to hear from you to know if we are there. If we are. Do you think, do you think sampling is likely to be a major job function for you, for a data analyst?
I think it is.
Think so?
It is, sir.
Okay. Okay. And definitely it's important for you to know it. It's important for you to know it. And you may find yourself in some places where you are involved in such experiments. You may find yourself in such an environment. However, in many job functions, you may not be involved in such because the data you are to work with already exists. They just bring the data for you to analyze. Do you understand? Usually data may be sourced from the business or something. So you are given the data to analyze, especially these days where much data is captured electronically. So most of the time, the data is already uh, collected, and then the data is given to you. So where your job starts is organizing the data, So you need to organize the data. You need to prepare the data, clean up the data, organize it, format it properly. If there's need to do normalization, you do your normalization, and then, and so on. And then you continue from there, pre-process, analyze, generate reports, create dashboards, and of course, interpret results of your analysis. However, it's good to know a little bit more than the average analyst out there. That puts you at an advantage. Okay. So no probability sampling. Here we have convenience as haphazard or accidental sampling. Members of the population are chosen based on their